Let's go to Liquid 1640, 765 map of Harris Peak. For this question, it gives us a two-dimensional array is grid, which give n multiplied by n grid, which has if this grid value is zero, means this is a land. If it is one, means this is a water. It let us to return the same size to a dimensional array. And it say that the height of each cell must be non-negative. And if the water cell is a water, it height must be zero. And it say that two adjacent cell must have absolute height difference at most one. So we want to find our assessment heights that the maximal heights in the matrix is maximized. Um, Return those kind of um, metrics. It say that just return anyone, right? Because it is possible. We just want to find the higher get one of the heights to be maximal. And so that what we think about is from the water to its neighbor, we increase by one, right? So we use the BFS um, to increase by one. For all of the waters, we enqueue. For the other cells, we set for example as minus one, right? And when we iterate those kind of cells from the queue, every time we look whether its neighbors, the four direction neighbors is minus one. If it is minus one, right, we are going to enqueue. And also we put the height to be current height plus one. So let's write code for this. We need the directional array, right? And so what we do is that we let's get into m equals this water length and n equals this water zero water length. So we see well our result will be new int m n. So we need a q. Let's put a int array as the for every cell, right? We include we put those kind of array. Um, um, those kind of positions like row and column into this int array to first new array. So what we do is set for int I equals to zero, I smaller than n, I am I plus plus. For int j equals to zero, is smaller than n, j plus plus. So let's say if this is water, right? It's water I j equals to one. Um, let we can set for example set um result I j equals minus one, right? So that means this is not visited. And if it is water, then we set this one as zero and also in Q. Result I j equals zero and the Q offer new int I j, right? Then we trying to say why this Q is not empty, right? Q is empty. Then we'll get current one. Uh, int current one equals q dot pull. And for the fourth directions, int k equals to 0 is smaller than int k plus plus. So what we do is that int new row equals current 0 plus d row k, and int new column equals current 1 plus d column k. So let's say if inbound, right, new row smaller than, if not out of bound, new row greater equal to m, or new column smaller than 0, or new column greater than m. And also if this kind of result new row new column doesn't equal to -1, right? That means this is already been validated. Then we're going to continue. Then we'll have result new row, new column equals the result current 0, current 1 plus 1, right? And also we need a enqueue offer new int new row new column. In the end, we just return result. Line 6. So let's say for this one, cause so this is k equals 4, smaller than 4, right? And let's also write a Python code for this as well. So we need the b row b column equals 1 0 minus 1 0, and this one equals 0 1 0 minus 1, right? And m n equals length is water, and the length is water 0. So what we do is that let's have result equals -1 multiply n4 underscore in range m, right? So q equals the QE. We may need import the deck from collections. Import QE. So let's say for I in range M, for J in range N. If ij, right? If ij equals if is water I j equals 1, then we have result I j equals 0, and also we need a q append ij. Then what we do is that while this queue is not empty, while queue um, will have a current row, current row, current column equals q dot pop left, and well, for k in range 4, we're going to have a new row equals row plus the row k, and also new column equals column plus the column k, right? So what we just say is that we need to check the boundary. If zeros if zero uh, new row smaller than zero, or new row greater equal to m, or new column smaller than zero, or new column greater equal to n, all results new row new column than equal to -1, right? In this case, so we need to continue. Otherwise, what we do is that we need to result new row, new column equals result row column plus 1. And also we have a queue append um, new row, new column. In the end, we just return results. It will be n multiplied by n time and space complexity as we iterate every cell once.